Hello everybody, this is Dr. Noor Badsha, University of Engineering and Technology, Peshawar, Pakistan. This is a new series of lectures about statistics and probability. So in the first lecture, I'll be talking about introduction to statistics. What is statistics? What are the main branches in statistics? What are the main tools in statistics, etc. So I hope everybody knows that what are the applications of statistics in real life problems. So the main purpose of statistics is to organize data, to collect data, to interpret data, to do some inference, etc. So what is statistics? As I said, the first part of the statistics is usually concerned with collection of data, which could be done through using surveys, which can be done by using some questionnaires. The survey could be done by that. We can do some experiments. Those experiments could be random experiments. These surveys, these data can be collected by observing something, some scenario. Okay, once we have that data in hand, that data need to be presented by using through statistical tools, which are obviously there are some charts we are using, tables, there are some graphs, etc. So you need to present the data, right, by using different type of graphs, and then once we have that, we could talk about the nature of the data, and then we characterize the data. That means representing the whole data by a single number. It could be average depending upon the nature of the data. It could be median, it could be quartile, it could be a mode, and so on. We also talk about dispersion in the data as well, how much data is lying away or close to the mean or to the median. Once we have done all that, this is a part of statistics which is usually labeled as descriptive statistics. I'm going to define that in a while. Whereas the second part, once we have done that, we need to make some decision, we need to do some analysis, we need to answer some questions. Why do we do that? Why is this thing happening? What would happen if we do that? Based on the available information, how could you predict about the nature, the behavior of that data in future? So combining all these concepts, we could simply define statistics is the science in which we conduct studies about collection of data, organization of data. Then we have to produce, we have to make a summary of the data, and once we had that data, to summarize, and then we do analysis of the data by computing different type of statistics. Like we can compute mean, we can find its variance, we can find its standard deviation, we can find many things. Okay, so that's a part of analysis. And once we have done all these steps, the next step is usually drawing conclusion from the data, where conclusion basically consists of prediction, making decisions, doing something related to the data, or etc. We can just check the hypothesis, we can do estimation if you talk mathematically. Obviously, it contains two parts. The definition consists of two parts. One, you should see that's in the color is conducting studies to collect, organize, summarize, and analyze the data. This is, as I said earlier, it's a descriptive statistics. Whereas the second part, in which we draw conclusions from the given data after analyzing it, this is the next part of the statistics. That's the next branch of statistics, which is termed as inferential statistics. Okay, where do we use statistics? I hope in every field of life, in every area of life, we can use statistics. I'm focusing on few of them, we can simply use forecasting, and we can go for demographics and economics. We can use statistics for construction and materials in engineering, whereas in sports we can simply use statistics to observe the performance of individual to performance of the team in a certain or in a specific sport. Okay, and obviously we can analyze, we can make some decisions about consumer preferences. We can talk about the financial trends. What are the financial trends, and how would it behave in future? For that purpose, obviously we can use statistics. Okay, let me talk about some basic tools which we are using in statistics. Let's define them. As you say, the very important term used in statistics is the variable, okay, which could be defined in a very easy way. We say it's a characteristic or it's an attribute which may take different values. Okay, and the next question is, what does basically variable do? Because once you understand what does variable do, you'll be understanding the remaining concepts as well, and statistics. So in statistics, we usually variable are categorizing, classifying, dividing the given data or given scenario. For example, if we have a one variable m which represents male students in a classroom, so what would happen? That variable m has simply divided the whole population students into two parts. One is male students and the other one is female students, right? If you say x is a real number, so what is basically x doing? X is classifying all numbers into two parts. One is the real numbers and the other one are the complex numbers. So whenever you talk about variable, okay, so that will be classifying, that will be categorizing the given data into certain distinct classes. Okay, right. So we usually consider two types of variables. One is obviously variable, and the second type is a random variable. So a random variable are those variables whose values are determined by chance. Okay, which basically means that if you do some selection for a certain population, and then we talk about a variable which represents specific thing in that selection. For example, if we are having in a classroom, if there are a certain number of students, let's suppose there are 33 male students in a class, and let's suppose there are 39 female students in a class. So if you talk about variable, we say m is a variable, whereas f is also a variable because it's classifying the whole population in two parts. And then obviously in this case, if m is the variable, so it will be taking, and it can take any value from those 33 students, and f will be a female student, so it can be a variable as well. But what do you mean by random variables? If I select a group from here, from this complete class, let's suppose I choose 10 students from this class randomly, right? So and then we say m is a variable which represents male students, and that selection, keeping in mind, we are not talking about m is the number is the students in the whole class. Now we talk about this selection. So number of male students in this selection, if m is representing that variable, so in that case m can have 0 value, because you might have selected all female students, we might have selected one male student and 9 female students. So you see that in this case the values of m are determined by the selection, how many students we have selected in this case. So in this specific case, when you do selection and m is representing that specific number of certain attributes, we call that variable as a random variable. Then we will be talking about random variable later on in coming lectures in detail, obviously. So once we have a variable, so there it can take some values, obviously, and then those values are what that they are assumed to be the data. The values of a variable, right, they are terms as data. You can call them data points as well. And then the set of all those data points, if you write that in a set form, in a collection form, in a combined form, so we call that data set. So usually this term is most importantly used in statistics. That data set is the set of the collection of all possible values of that random variable or variable. Okay, then we talk about population, because once we have a data set, so we may consider that data set as a population, and it could be considered as a sample as well. So you see, it is the set of all possible outcomes which are to be studied. There is no specific rule for a certain data set to be considered as population, because a set in one type of study can be considered as a population, whereas in another type of study the same set which was considered as a population may be considered as a sample. Okay, so a population consists of all subjects that are being studied, whereas sample is simply a subset of what? A subset of population. You take some part of that population, right? So that will be, for example, if you talk about a specific university and you talk about a specific class of students, so the university will be considered as a population, whereas that class will be considered as for example, a class of students who are studying statistics. So that will be what? That will be a sample in this case. Now the sample was in the previous example was a class of students studying statistics, but if we consider some students, we pick some students randomly from that class, which we have those students who are studying statistics, and there might be female students, there might be male students. When we talk about only female students, so that female students will be considered as sample, whereas the classroom which was considered as sample in previous case will be termed as population now. So it depends upon the nature of the study, which type of study do we do. Okay, as I explained earlier, there are two types of areas of statistics. The first one is the descriptive statistics, in which we do collection of data, organization, summarization, presentation, analysis of data. Okay, so whereas in case of inferential statistics, what do? We do generalization from samples to population by doing estimations, or we do hypothesis tests. Okay, we can determine the relationship between the variables, and we can make some predictions as well. The relation can be found by using regression or correlation, etc. Okay, so you see that from here you can just understand the concept of descriptive statistic symbolically or geometrically. When we do some analysis, when we do some collection, when we do some calculations by through averages, quartile, quantiles, and etc. Whereas in case of inferential statistics, what do? We do some calculations for a small amount of data, and we make prediction about the whole data, about the large data, which is termed as population, and this will be a sample. So when you take a sample, we do some calculations, and then we basically make some decisions about the whole population. Okay, now we talk about types of variables. There are many types of variables. Okay, so the first one is qualitative variables, and these are the variables which are obviously based, or which are doing classification based on the quality. Okay, it is dividing the given data set, the given scenario, the given problem into distinct groups based on some characteristic, based on some property. are based on some attributes. Those attributes could be anything, like they could be the color, they could be the gender, that could be the religious preferences, that could be language as well, that is favorite subject, that could be based on favorite sports, etc. So we can do those classification through some specific characteristics. Okay. Whereas in case of quantitative variables, if you do classification based on some quantity, if you do quantification, right, so we say that they will be having numerical values, because we can do quantification through numerical values, and they could be order or rank, they could be put in order as well, from smaller to larger or from larger to smaller. Whereas qualitative variables, they may not be put into some order, or there might be no rank defined in qualitative variables. Okay. Examples are the age, because you see age is numerical and it is doing classification. Keeping in mind if we talk about age, so age is a quantitative variable, but if you talk about the like a child, and then we have a young one, and then we have a senior citizen, etc. If you do that classification in that way, so it will be a qualitative one, this will not be quantitative. But if you talk about ages, like we say from 1 year to 10 years, from 11 years to 20 years, from 21 years to 30 years, so in this case they could be put in a order, and they are numerical quantities. Okay, so the age is what, that is numerical. The same thing with the height, and the height as well, because the height is a numerical quantity. Okay, and obviously it can be categorized as well. So height, age, weight, length, all these are what they are, quantitative variables. Okay, body temperature is also a quantitative variable. Okay, how do we classify these quantitative data? Quantitative data basically divided into two groups. We call the first one is discrete, because we do quantification in two ways. You do counting or you do measurement. So if you do counting, right, for a quantitative variable, if you do counting, if you compute its value by counting something, so it will be termed as discrete variable. Okay, whereas in case of measurements, if you do measurement, right, so measurement will lead you to a variable with continuous behavior. Okay, so continuous variable can assume an infinite number of values between any two specific numbers. Okay, they are usually obtained by using measurements. Okay, they can have fractions, they can have decimal points as well. It can assume an infinite number of values in a specific interval. Examples of continuous variables are obviously temperature, that's height, that's the weight, that's the mass of something. Whereas when you talk about number of students in a certain class, in a certain course, in a certain subject, number of players, number of matches played by a certain team, so all of them are discrete variables, whereas the other examples are weight, height for continuous variables. Okay, there is a very important concept to use in statistics, that is introducing some boundaries. And why do we do that? You do measurement, the measurement is not always perfect. For example, if you say length of a certain object is 15 centimeter, but that is basically the recorded value, it's not the actual value, and we cannot find actual value because it depends upon the measuring machine you are using. So we usually consider its boundaries. How do we introduce boundaries? This is a whole number. So in case of whole number, we simply take 0.5 away from it, and we add 0.5 to it as well. So 15 minus 0.5, that is 14.5, whereas 15 plus 0.5 is 15.5 centimeters. The same thing for this one. It's also an integer, so you can simply have 85.5 because you subtract 0.5 from it and you add 0.5 to it. Okay, whereas in case of time, if we have time for 0.43 seconds, so what we do, you see now this is not a whole number, it's a decimal number. So 0.43, we are having two decimal place number So what would you do? You would simply subtract 0.005 and we would add 0.005 to this number to get the boundaries for it. In case of one decimal place, you see that it's 1.6. We'll be adding and subtracting 0.05. Okay, from it, subtract 0.05 from 1.6, that will give you 1.55. That's the lower bound. Whereas if you add 0.05, it will give you 1.65. That's the upper bound. So this plays very important role. Later on, we'll be talking about it. Okay, right. There are some measurement levels for those variables. So we call them measurements. Scales are measurement levels. The first level of measurement is usually named as or termed as nominal level of measurement. It is clear from the name. Okay, that will be categorizing, will be classifying the given data, the given information based on their names. Okay, so they will be categorized through their names, through some property, but there will be no specific order or rank imposed on it. You cannot put them in order. Okay, examples are, you see that a sample of college instructors, they are classified according to subject taught. Okay, English subject, history, psychology, statistics, or mathematics, etc. Because you see that instructors in a college for different subjects, we cannot put them in order. There is no specific order to be imposed on in it. Right. So classification, the further examples are gender, zip codes, political affiliations, religion, and marital state as well. So all these are examples of nominal level of measurement. The next one is ordinal level of measurement. Okay. So in this case, what do we do? Is classify the given data into categories which can be put in order. It's clear from the name ordinal. So they can be put into an order, can be placed into a rank, specific rank, but there will be no precise differences between the ranks. Okay, that's rank 1, rank 2, rank 3, rank 4. There is no specific difference between two classes or two ranks. For example, if students are doing some evaluation based on agree, strongly agree, disagree, strongly disagree, so this is obviously an ordinal level of measurement, because they are in a specific order. We take agree, strongly agree, and then we say disagree or strongly disagree. So they can be put in order, but there is no specific relation between specific difference between the two classes. Okay, we can talk about ranking of guest speakers. Okay, they can be ranked as a superior one, average one, or poor one. Again, we usually put them in order: superior, average, or poor, or we can put them in poor, average, and superior order as well. Okay, we usually talk about grades of students as well: A grade, B grade, C grade, D grade. I'm not talking about GPAs, I'm talking about grades. So grades are what they are, basically the ordinal level of measurements. Similarly, different post, teaching post, etc. Playing rankings or agreements and grades are further examples of ordinal level of measurements. The next one is interval level of measurement. It's obviously ranking the data, classifying the data. There will be a specific rank as well. It can be imposed on it, and there will be a specific difference, precise difference between two classes or two groups, but there will be no meaningful zero. Now, what do we mean by meaningful zero? We can have two types of zeros. One is usually termed as meaningful zero, whereas the other one is a non-meaningful zero. Zero basically means nothing, but there are some situations in which zero doesn't mean nothing. For example, when we talk about zero temperature, it doesn't mean that there is no temperature. Okay, we say zero IQ level, so it doesn't mean there is no IQ level. When you talk about zero GPA, it doesn't mean that the student has not done anything in the exam paper. So these are what? These are non-meaningful zero. But when you say 0 students in the class, so that means there is no student in the class, so that will be a meaningful 0. So when you do classification based on IQ levels, temperatures, and SAT scores, etc., GPA as well, they are all what? They are examples of interval level of measurements. The last one, the fourth one is the ratio level of measurement. So in case of ratio level of measurement, obviously it will be possessing all characteristic of the interval one, but there will be a true 0, there will be a meaningful 0. For example, weight, height, length, etc., they are all what? They are examples of ratio level of measurement. When we do classification of data based on weights, it will be ratio level. If you do that by using height, so again it will be a ratio level, and so on. Okay, these are some more examples. Zip codes, they are nominal level. Gender, eye color, political affiliation, religious affiliation, favorable subjects or fields, they are all nominal, whereas grades, judging, rating scales, ranking of players, etc., they are all ordinal level, whereas in case of interval, SAT, IQ level, temperature, GPA, they are all what? Interval level of data, whereas in case of ratio, height, weight, time, salary, age, keeping in mind, we usually use grades as A, B, C, D, F, so they are all ordinal. But if you talk about GPAs, the CGPAs or GPAs, they are interval level, whereas marks in a paper or an exam, that is representing ratio level of measurement. Okay, so altogether we can have all the data type can be expressed in the following table or following block diagram. Types of data, we usually have two types of data, that is quantitative data, right, or qualitative data. Where qualitative is specifically they are non-numerical, and they could be nominal or they could be ordinal. Whereas the quantitative data, that is classified into two groups, is discrete and continuous. Discrete is basically do classification by using counting, whereas continuous is doing it by measurement. So again it is divided into two groups. It could be interval scale or it could be a ratio scale. Okay, so look into this example. You may pause the video for a while and you should answer these questions, and once you have done that, you can simply check the answers as well, so the answers are given by these, right. So if you have any query, you can simply put in your query in the comments section. So thank you very much. See you in next video.